The future belongs to those who understand data, and every click, every number, every decision, and powered by intelligence. With Python, you don't just analyze data, you control it. You visualize it, and you turn it into opportunity. At EDXcellence, we train you with real-world projects and practical skills. Master data science with Python. Build your future with EDXcellence.
Is my screen visible? Okay, Sharique. Very good. Now we're gonna learn about the two things, which is regression model. There's four-part in regression model. One is a regression model plus regression matrix and logic regression plus matrix classification. This all comes under regression models. What is the regression? What is the regression model? How do we do it? We're gonna learn everything. Now, machine learning problem types. Regression model are usually are predictive numbers. When you have to predict something in a numerical form, we use regression model. Classification, predict category. If you have to predict a category, particular category, then this category will how good this category is gonna perform. Or if this product goes well, it falls is going to be in which category. We use classification. Number four, three is clustering. Clustering, I think I've explained also many times, and as the name suggests, it grouping the data, grouping a similar type of data, like suppose grouping a students of same class. It's called clustering. Okay. Now, what is regression? So regression used when used when output is continuous. Example: salary, house price, temperature. Should be numerical. Now, linear regression, it shows a graph. The graph which is in a straight line, and the graph equation is y is equal to mx plus c, where c is a constant. I think you all know this formula. It is a pretty famous formula you have used in mathematics and many more places, and physics also, where m is the slope and c is the intercept or constant. Okay, and x is the variable, and y is the answer you want. Okay. Now, how model learns? Use latest square method and minimize square error. Loss is equal to actual minus predicted the whole square. What it really means is how models learn is it uses the squaring the method. Means it square a particular number, then minimize the square error and do this formula, which is actual minus predicted. We see the difference. What is the actual result and what is the predicted result? We get minus result. We minus we minus predicted from actual and get a square of it, and we get the loss. I think train and test split I have already explained you several times, which train data is equal to learning patterns. If you have to learn patterns, we have to train data. We split data into train and test. We train data on modeling a particular data, which learn the learning patterns. We learn the patterns and the categories, and we test the data. Why we test the we test the performance through a data called test data. Why we test the data? To evaluate the performance or evaluate the thing which I've taught to the which we have taught to the model is and seeing that this is our model performing well or not. Okay, and preventing overfitting. What is overfitting? Overfitting, I've already explained to you, is If overfitting means giving more answer or not accurate answer, good more predicting more than one value, more answer predicting. Then we have realization Python code. So like I will explain you in the Jupyter notebook. We will go in the Jupyter notebook. And what are regression metrics? So we have four regression metrics, which is MAE, MSE, RMSE, and R2 score. If you have remembered, I have already explained you in previous classes, and I have told you we will come to this again when we learn the regression model. I think you all know about it. How many do you know about these models, which we have already discussed? That in a chat box. How many of you know about these models, or do you know remember nothing? If you don't know anything, tell me. I will just explain it again. But please write something in the chat box, guys. No, I think the our interaction should be there should be an interaction between us. Anyone? Archit, Rashmi, Vishali, Sakshi. Repeat again. I will no, don't know about these much more. I have explained the heard about RMSE. Okay, I will explain it again. No problem. I have explained these topics in the last two. So what about R2? I will explain this sure right now. I have already explained you these topics in last. If you're gonna see the probably I have shared the video also where we have learned the mean square root mean square method. What are these? I have also shared the videos also of this regression model. Like MAE, which is mean absolute error, how to interpret it. I have already explained you. I will explain it in the once again. But please try to remember it. We're going to do the practical of this. We have already explained the theory of this. Okay, I will explain the article score, but I will just go over just give the overview of these right now, and we're gonna do the practical right now in the Jupyter notebook. Okay, so first we will start with MA, which is mean absolute error. The formula is equal to average divided by actual minus predictive, which is it is easy to interpret and less sensitive to outlier. We use this regression model to calculate the evaluation. MAE is equal to average divided by average into mod actual minus predictive. The actual value we got minus the predictive value means that it is the loss into the average. We get the mean absolute error. Then we have MSE, which is mean square error. What is mean square error? Mean square error is equal to average into actual minus predicting ka whole square. As you can see, the square says that we're going to square the actual minus predicting. Uh, See the whole line shows you the formula. Here mean is equal to average, square is equal to the squaring the numbers, and error is actual minus predicting. Okay. Finalize large error used in optimization. And then we have RMSE. RMSE just we're gonna root the mean square error. We calculate the mean square error. We put an root under mean square error to get the why we do this, because we square the error, so the original value get double. So we're not getting the original value. To get the original value, the original answer, we mean square it, root mean square it to get the actual result, to get the original result. It is easy to interpret. Then we have R2 score. R2 score measures the variance explained, but it shows a range that from where to where a particular thing is going. So like 0 to 1 example, or 0 to 100 over given the example. Okay, so where 100 is equal to perfectly fit, and 0 is equal to poor model. As suppose Suppose model 50 is there, which is equal to moderate model or middle model. No, moderate model, like this. Suppose 25 is there, which is less moderate, which, then 75 is there, which is more moderate, like this. R2 shows a range of the. Now get it, Shubham, what R2 score is? Who asked R2 score about that? Yeah. Now you get the overview of these all four. We're gonna do the practical also right now. Got it. Okay, good. Shubham. All right. Okay, after covering the R2 score, first I'm doing all the theory part, then I'm going to do the practical part. Then we have classification. Now, why we do use classification? As we have already discussed here, classification used to predict categories. We are searching. We have covered regression model, the regression metrics also. Now we are searching the classification metrics and regression logic regression. Is classification output is categorized. We categorize a particular output. We classify the output into putting the output in a particular category. It's called classification. Like for example, if a email is spam or not spam, example pass or fail. If a student is passed or fail exam, like this. A simple example of this. Why not linear regression for classification? Because we can put zero greater than zero, or smaller than zero, greater than one, not substitute for probability. Now, what is logistic regression concept? Used in symbioid function, and this is the your formula. We're gonna explain it in the more precise way in the practicals, which is sigma into x is equal to 1 by 1 plus e to the power beta minus x. Output is provided between 0 to 1. Then we have symbioid curve explanation, which is converting the linear output into a probability. Logistic regression means converting a simple linear thing into a probability. Like if probability is 0.5, then class 1, else class 0. Like we use do while loop type kind of thing here. Then you have Python code of here also. Then we have confused matrix. When we have confused matrix, like true positive, true negative, false positive, and false negative. We're gonna learn one by one. Now, what is accuracy? Accuracy is equal to true positive plus true negative divided by total. Means if we are working on a model, and model, let's take example of a hospital where 100% patient got tested for something. You know, out of 100, the model predicts that 60 patients are positive of a particular disease, and 40 patients are negative of particular disease. Means 60 people have disease and 40 people not have disease after testing 100 of patients. Now, out of those 60s, we can see. Uh, can I have a just? I will just. There is no brush. Okay. See, we have 60. Sorry. That is the revolve. Yeah. So we had total have 100 patients. Okay. We have 100, out of which 60 are positive, no, and negative are 40. Okay. Okay. These are positive and these are negative. Out of which, what is true positive? True positive means The suppose out of these 60, which is this is the predicted value. This is a predicted value. Okay, these are predicted value by our model. Out of these 60s, the actual patient who have disease is 50. Okay, and 10 patient who don't have disease, they are predicted falsely. Out of these 40, suppose 25 people don't have disease. Okay, sorry, 25 people have disease and 15 people don't 15 people don't have disease. 25 people and 15 people have disease. Okay, these have disease and these don't have disease. What is really mean here is, see, these values are predicted positive and actually they are positive, so they are true positive. Okay, they are true positive, true positive. And here they are rated positive, but actually they are negative. So they are true negative. They are true, but they are negative. Sorry, they are false positive. They are positive, but they are false. They are not true. So they are false positive. Okay. Here, out of 40, which are predicted negative, 25 are negative. So they are true negative. Means they were predicted negative or they are actually negative. So they are true negative. It is the less 15 are false negative. But why is false negative? Because they were predicted negative, but actually they are positive. So I think you got what is true positive, true negative, false positive, false negative. Okay. Now we come to accuracy. How are we going to calculate accuracy? So accuracy means combining true positive plus true negative by total. Means uh, the accuracy, the literal meaning of accuracy is the predicted how many the prediction which was done by our model is correct or not. We have to evaluate the prediction which was done by our model is correct or not. Why we do this? We do this to evaluate our accuracy. And how do we calculate accuracy? By choosing all truly predicted model, which is true positive, which is they were predicted positive and they are actually positive also, true positive, and true negative, which they were predicted negative and they are actually negative also. So we're gonna add this, means 50 plus 25, which is 75. 75 by total is 100, so divide by 100. It will be equal to 3 by 4, no, or 0.75%. Okay. Now we have precision. What precision is equal to total positive by true positive or false positive. Now, true positive is 50. Okay, divided by true positive 50 and false positive is 10, which is equal to 50 by 10 by 60 is equal to 5 by 6. It is answer. What is precision? See, accuracy doesn't give you the most accurate result or most precise result. That's why we use precision. Now, precision takes the total positive value you got. How many the true positive value you got is from how many positive value, the total predicted positive value that you predicted that these are going to be predicted. How many of them are accurate, are truly positive? Total positive value you predicted, how many of them are truly positive? We calculate that. So we calculate our positive value predicted by us by the truly predicted the correct predicted value of positive, which is 50 by 10, 50 plus 10, which is 60 by 50 by 60, which is equal to 5 by 6 here. Now recall is important when false negative is costly. How do we calculate this? We calculate by true positive means 50 by True positive means 50 plus false negative. What is false negative? False negative is which is predicted negative, but actually it is positive. It is here 15. Here 15, which is equal to 50 by 65. Okay. So we 10 by 13. So we're gonna divide it, we're gonna get the answer. Okay. Now, why we do call recall value? See, as you can see, recall value in recall value, there are total actually true predicted true positive value. See, here 50 are a true which are actually predicted true, and actually they are true value, and here 15 where it is predicted false but they're actually true. So means total true value is 50 plus 15, which is actually positive value, and the rest is negative. The actual result, not the predicted result. The actual result is 50 here is positive and 15 here is also positive. So it's calculate the out of total actually positive cases, how many we predicted correctly. So we calculated it through our recall value. Okay. Now we have F1 score. What is F1 score? So F1 score combines all, means precision into recall divided by precision plus recall. Why we do this? To best for imbalanced data set. But there is many more data which is imbalanced, and we calculate F1. We calculate our recall value, accuracy, precision. So there are more different values. So to get a more accurate result, or more the more accurate result, or result the one result which we can trust, so we combine all the results. How do we combine? We combine through precision into recall by precision plus recall. Okay, and we're going to get the answer. Why we use F1 score? Because we have many scores which are correct, which is recall and precision. So combine all in one, we do the F1 score. And in any project, F1 score is very important. Accuracy is also important, precision is also important, but F1 score is important. Okay. See, now we have relation versus logistic regression. Regression is continuous output. Logistic is category output. When you have a continuous output, we use regression. When we have a category output, we use logistic. Regression use MSE, which is mean square error, and logistic use log loss. Then we have real-world application. This is not important, and we have key point outputs. These are all we will explain. Now we come to the practical part, which is I'm going to show it with your DSC. Just wait, guys. Wait a minute. Just a second, guys. I must open my codes. Yes. So you got the relation idea, na? We use the relation to for a continuous value. If you want to predict we have to predict a continuous things going on, and we have to predict a particular value, what is going to be result if these things carry on. We use the regression model, and through regression model we use linear regression as a first thing. Okay, and to use linear regression we use some codes. And what are the codes we use? We use just a second. Sorry, guys, just a second. I'm very sorry. I have just messed up my codes. Yeah, I have got the codes for regression. See, we import numpy and numpy as np, the first thing. From Scikit-Learn model import linear regression. We have to import this from Scikit-Learn model. What is Scikit-Learn model? It is a model where the linear regression libraries are saved. Okay, So when you have to predict a continuous value or a slope, a continuous value, we use linear regression. Okay, from Scikit-Learn. So Scikit-Learn is really important. Why Scikit-Learn is important? See, this is one more libraries. I will not gonna explain you every libraries. You gonna learn the libraries as we progress in our course. Okay, so you're gonna learn the Scikit-Learn model, importing from and from Scikit-Learn model, we gonna import linear regression. Okay, so input must be in 2D. So get the two direction model. So because it works in a slope, and the slope here will be a x-axis and y-axis. So x-axis number will be 1, 2, 3, 4, and y are 3, 5, 7, 9. Model linear regression. We're gonna fit xy. So what we gonna predict? Prediction is equal to model predicts 5. Okay, models gonna predict 5. Print prediction sadly, which is this prediction sadly, prediction, which is what we're gonna predict. We're gonna predict 5. So we got our answer 5. If you're gonna change this, and let's see what we got answer. If you're gonna change the answer, we got our prediction 13. Okay, if you're gonna we're gonna predict 6, our prediction sadly will be 13. Okay, and we can change these also. Suppose these are the mm, suppose these are the number of months or hours, and of months of working, and these are the employee number or something which employee experience, it's for employees experience. According to this, we calculate the salary. It can be anything. I've just given you a particular example. Okay, and how we calculate this? By using the formula, which is y is equal to mx plus c. Y is equal to mx plus c. We will use the formula to get the answer. This, where we have our y, where we have our x, you know, where we have our c also. C is constant given, and we calculate the c is equal to this, and we calculate the value m. We don't want to use the practical, the calculate the whole thing by ourselves. The computer does this for ourselves. We just gonna put this code. This is a simple code I have given to explain you. Okay, do you got this? It is a simple example of a linearization model. Do you have any doubt, guys? Guys, we got this, or do you want me to explain it once again? Guys, do you got this? Now we're gonna move to mean square error also, mean absolute error, which is average by multiplied by average predicted value. Guys, do you got this? Yes or no? Okay, Vishali. Now we are gonna continue with mean absolute error. So we're gonna mean absolute error. We're gonna calculate from Scikit-Learn matrix. We're gonna import mean absolute error. See, Scikit-Learn is very important. In the Scikit-Learn, we're gonna import all logistic regression model, which is category key, mean square absolute error, then regression, linear regression. We're all gonna import from the Scikit-Learn. So learn this thing is very important. Learn this Scikit-Learn very important. Now you're gonna use this code. So y predict model predict x. What we're gonna predict? We got MAE, which is mean absolute error. We're gonna put y that's predict, and we're gonna predict the MAE. we have not given any data, so the MA will be 0. Okay, just to give you an example, what the code we have provided, we've given you code. I will give you some more codes about see mean square error. How we're gonna calculate with mean square error? We're gonna use this mean square error also. For mean square error, the same thing we're gonna go do. Everything is same. The main thing is different. Only we're gonna use here we have mean absolute error. Here we have tried mean square error, and the rest is same. Similarly, we have after mean square error, we have we're gonna use mean absolute mean root mean square error. But here we don't use Scikit-Learn. Why? Because we already have this answer. We have to do this RMSE. We have to just root under it. By giving the root under it, we just to have to import, do it. We can do it through NumPy also. Okay. After NumPy, we're gonna calculate the R2 score. What is R2 score? I have already explained you. It basically gives you the particular range. The particular range it gives you the codes for auto score will be here we calculate our auto score. Okay. I have some more codes also, so we can calculate all these things in one. Uh, where is the code? Where is the code? Where is the code? Yeah, see, I have explained you it in a different code, but you have to do all these things. You just have to add one code, so complete all these things, four things in one. So you have to import from Scikit-Learn matrix or import mean absolute error, mean square error, R2 score, and import NumPy. Now we have to give this code for mean absolute error, mean square error, and R2 score error. Through this, we're gonna calculate our answer. And there is some mistake we can do this, correct this code laterally. As you can see, this is the example. We can use this code, so we don't have to write every code one by one. We have to combine, or we can combine all these codes to get in more idea. You can use ChatGPT also, so get in more idea of it. Okay. Now, we were working on a train test model. We're gonna train test more thing, which is our accuracy. I will share you the accuracies also. Just a second, guys. Wait a second. I will just calculating. But till here, do you have got any problem? Please answer me. I am listening. I'm listening. I'm going to chat right away answering chat box. I will get the more codes over here. Okay. Till now, I'm writing the codes, but till then, just do you have any problem? Just write it. I can explain the two more codes. Then we'll be done today. Okay. For your better understanding, we can gonna give you the example. Okay, guys, now I'm gonna share the screen. I am waiting the code. Okay. As you can see, here first of all we have to import our libraries, which is import numpy as np. My screen visible now to you all. Give me a thumbs up if my screen is visible to you all. Chalo, good. Okay. Now from Scikit-Learn we have to import regression libraries. Then we have to import our mean absolute error, mean square error, R2 score. Then from Scikit-Learn model, we have to import train speed also. So we can cover speed also now. Okay. First of all, we have to create database, which is experience versus salary. So if someone experience is this is going to be experience 1, 2, 3, 4, 5, 6, and this is going to be your salary. Okay. And train size is equal to 0.3, and random set is equal to 0.4. This is a code for train case. Train X, test X, train Y, test Y, and we're gonna train test speed right now. So X comma Y, test size equal to 0.3, and the random set is equal to 0.2. So model, now which model we're going to use? We're going to use, first of all, we're going to use our linear regression. Linear regression model fit train test. So as you can see here, we have done the linear regression model. We have just given database and we have just fit linear regression model and pick the cell. Similarly here also, we are given a test, the same thing. We have given that model linear regression. We are importing the model. We are given the database. And after this, we are given the train testing also. We have also calculated the mean square error, which I've given here, given the code here. Mean absolute error, which is given the code here. RMSE, which is here, and root square merit, which is here. Okay. And what we have to predict? We have to predict actual value, which is y test, predicted value, y predicted, model evaluation matrix, ME, MSE, RMSE, R2. And here we got our answer. So our actual value is 472. How we get the actual value? By training testing method, we get the actual value. Predicted value is this. So predicted value is different from our actual value. So the model evolution. Now, MSC is equal to this. Mean absolute error. Mean square error is this. RMSC is this, which is the root mean of this. And the R2 score will be this. We can change something also, like if we just we just add 40. I messed up. Sorry, sorry. Okay, I want to check this code 1 second. But here you can see the our answer we want. We got our answer. Okay. Now similarly, we have to calculate the accuracy also. We have to just write a simple code for accuracy also. Uh, just wait a second, guys. Just a minute. Just I have the code for this also. Just a second, guys. I'm searching the code I have written here. Just a second. No. I'm going to write the code for accuracy, precision, and recall and F1 score all in one. So we can get an idea. Uh, where I have written, I have written somewhere. Okay, I'm not getting the code. I've just gone ChatGPT and I show this code from ChatGPT only. I'm not getting my codes which I have written. Yeah. See, and there we have imported NumPy library. If we have imported logic regression, train test split, and we're gonna import from Scikit-Learn our accuracy score, precision score, precision score, recall score, and F1 score. Here we have the create database which have house ready. So this is a database which we have created. It will always in a 2D format. It should please learn these things. And these are train test split. Okay, we're gonna train and test the split to make our model predictive. We have created a model or estimation. We have created the model train test model. Now we're gonna predict what we're gonna predict. We're gonna predict the confusion matrix, which includes accuracy, precision, recall score, and F1 score. We're gonna calculate these and see these are answer we got. We got our F1 score, we got our precision, we got our recall value, and we got our F1 score also. Okay, these are the codes. This is how we wanna write these codes. Okay, is everything is clear now? And yeah, that's it. That's a whole explanation of the accuracy thing. Okay, guys, I'm waiting for two more minutes. Do you have anything to tell? You can tell. If you don't have, you can leave. But if you want to leave, give me a thumbs up. If you got the this lecture, I'll share the video also and the screenshot of codes also, and you can leave that lecture. Thank you.